Good morning, students. Today we can see what do you mean by analytic functions. So let us see the definition of an analytic functions. A function f of z, is said to be analytic at a point z naught if f is differentiable not only at the point z naught but at every point of some neighborhood. So it should be differentiable not only at the point z naught but also in some neighborhood of the point. Then we say that the function f of z is analytic. So we can say a function f of z is analytic in a domain if it is analytic at every point of the domain. Then only you can say the function f of z is analytic. And next one, the necessary condition. What is the necessary condition for a function f of z to be analytic? The necessary condition for a function f of z equal to u plus iv, here u is the real part and v is the imaginary part, to be analytic at all points in a region plane in a region R, or ux equal to vy and uy equal to minus vx, and provided that ux, uy, vx, vy exist. Next we can say the sufficient condition. The sufficient condition for a function f of z to be analytic is the sufficient condition for a function f of z equal to u plus iv to be analytic at all points in a region R, or first condition is ux equal to vy and uy equal to minus vx, and this one we call it as a CR equations or Cauchy-Riemann equation. And second condition, that ux, uy, vx, vy are all continuous, they should be continuous functions of x and y in the region R. So this one we call it as a sufficient condition for a function f of z to be analytic. So let us move on to one example how to determine whether the given function is analytic or not. So here f of z is equal to 1 by z. You have to check whether the given function is analytic or not. So let us take w equal to f of z. What is f of z? It is u plus iv. So u plus iv equal to 1 by x plus iy. Now multiply and divide by the conjugate. So here your w is u plus iv and z is equal to x plus iy. Clear? So multiply and divide by the conjugate. So in the numerator you have x minus iy by, and in the denominator you have a plus ib into a plus b into a minus b, that is a square minus b squared. So x squared minus I squared, it becomes positive since the value of I squared is 1. So x squared plus y squared. So that is your u plus iv. Now when you compare the real and the imaginary part, what is u here? U equal to x by x squared plus y squared, and your v is minus y by x squared plus y squared. I am comparing the real parts and the imaginary parts. Now you have to check whether the CR equations are satisfied or not. Now what is ux? Ux is dou u by dou x. That is a partial differentiation with respect to x. So apply u by v method. So x squared plus y squared the whole squared, and x squared plus y squared, x squared plus y squared, and the differentiation of x is 1, and minus x into differentiation of x squared is 2x. So you will be getting it as y squared minus x squared by x squared plus y squared the whole square. So this is your dou u by dou x. And similarly, when you have dou u by dou y, that is uy, so there you will be having it as, that is dou u by dou y is x squared plus y squared the whole square, and x squared plus y squared, and differentiation of x is 0, minus x into differentiation of y squared is 2y. So it is minus 2xy by x squared plus y squared the whole square. So this is your ux and uy. Similarly you have to find out vx and vy. So what is vx? Vx is dou v by dou x. What is dou v by dou x? So here it is denominator squared, so x squared plus y squared the whole square, 0, and then plus 2xy, and vy, that is dou v by dou y. Dou v by dou y is x squared plus y squared the whole square, and x squared plus y square into, and differentiation of minus y is minus 1 minus y into into 2y. So you will be getting that vy as y squared minus x squared by x squared plus y squared the whole square. Now when you compare, you have ux equal to vy and uy equal to minus vx. So therefore your CR equations, that is the Cauchy-Riemann equations, are satisfied. Cauchy-Riemann equations are satisfied, and therefore the function f of z is analytic. Now you have it in polar form also. What is the CR equations? In polar form. So dou u by dou r equal to 1 by r dou v by dou theta, and this is one equation. Dou u by dou theta equal to minus r dou v by dou r. So this one we call it as a CR equations, that is a Cauchy-Riemann equations in polar form. And next we have harmonic functions. What do you mean by harmonic functions? Any equation which satisfies the Laplace equation, that is u of x comma y. If u of x comma y satisfies the Laplace equation, then we say that u of x comma y is harmonic function. So let us see one example in this, how to check whether the given function is harmonic or not. Let us take u is equal to x squared minus y squared, and u is a function of x comma y, and dou u by dou x, that is ux. So when you partially differentiate with respect to x, you will keep y as a constant, so it is 2x, y squared becomes 0. Dou u by dou y equal to, that is uy, that is minus 2y. And what is u double x? U double x is a differentiation of x, that is ux again, so it is 2. And u double y is what? Minus 2. Now u double x plus u double y equal to 2 minus 2 equal to 0. Since dou square u by dou x squared plus dou square u by dou y squared equal to 0, so therefore the given function is harmonic. Therefore the given function is harmonic. So next we can say that Milne-Thomson method, that is construction of analytic functions. How will you construct the analytic functions? And here you will use the Milne-Thomson method. So here Milne-Thomson method. So using Milne-Thomson method also you can find out the construction, that is you can construct the analytic function. And so we will see that construction of Milne-Thomson method, that is when the real part, there are 3 types. First one is when the real part is given. So when the real part is given means, that is u is given. When u is given, how will you construct the Milne-Thomson? How will you construct the analytic function using Milne-Thomson method? So your f of z is line integral pi 1 of z comma 0 minus I into pi 2 of z comma 0 dz. And here what is pi 1 of z comma 0? It is dou u by dou x by putting x equal to z and y equal to 0. And what is pi 2 of z comma 0? It is dou u by dou y at x equal to z and y equal to 0. And similarly you can find out, that is when the imaginary part is given, that is you can construct the analytic functions, that is type 2 when v is given, that is when the imaginary part, when v is given. So here your f of z is line integral pi 1 of z comma 0 dz plus I into integral pi 2 of z comma 0 dz. And what is pi 1 of z comma 0 means? That is, it is dou v by dou y at x equal to z and y equal to 0. And pi 2 of z comma 0 is dou v by dou x at x equal to z and y equal to 0. So after finding out dou v by dou x and dou v by dou y, so you can substitute x equal to z and y equal to 0, and then you can find out the analytic functions f of z when the real part and the imaginary part is given. So the problems we can see in the next video, and thank you for watching.